So we are looking at drawing out covalent bonds in this video. You do need to be able to draw atoms to be able to complete this video, because that's our first step in drawing covalent bonds. If you don't know how to, or you don't know what I'm talking about, please go to my other video where it's on about ions, atoms, and calculating the number of protons, electrons and neutrons. It will help you massively. So the first step, like I said, is going to be drawing atoms. And fluorine, that's F2, that's a type of covalent bond we're going to draw first. And what you need to do to start with is draw the atoms. So number 9, or the lower number is 9, so that means that's the number of electrons. So I'm going to draw fluorine atom. First shell, maximum of 2. Second shell is a maximum of 8. We've only got 9 though, so we can only fit 7 in the outer shell. I'm going to draw the same out for the other fluorine atom. I am going to draw it with dots like I did for the ionic bonding. That is simply to show that they are different electrons. So 2 in the first shell, and then in the second shell I'm going to draw 7 again, because obviously fluorine has only got 9 electrons, and so we can only put up to 9. Next question I asked myself is, how many electrons do they need to get a full outer shell? So fluorine wants 1 extra electron, so it's full, like I've said before. This fluorine also wants 1 electron, so they are the same, and the only reason I am separating this out at this point is because yes, they're the same for this type of covalent bond, but not all covalent bonds are just 2 of the same atom. Okay, so it is important, even though it's at the minute I'm writing the same thing, to write the same thing out, because then when we get to the trickier ones we'll have that process of drawing the atom, working out how many electrons they need, and it'll allow that flow to happen more nicely. So what I've done so far, drawn out the atoms of the 2 things that are in that covalent bond, worked out what they need to get a full outer shell. For each of these covalent bonds, I want you to simply draw the atoms of both of them out, so 2 Cl atoms, and then tell me what each of those Cl atoms will need to have a full outer shell. Pause the video now and then we'll go review your answers. So you should now have had a chance to have drawn out the atoms for these 3 covalent bonds and told me what they each need. We're going to go through Cl2 together. So chlorine atom has 17 electrons. So that first shell, I'm going to draw 2, second shell 8, and the final shell, that's getting us up to 10. It's got 17, so it would be 7 in the outer shell. Same again, you draw the other Cl atom like we did earlier, but with dots, just to show it's a different atom, make your diagrams really clear. So 2 in the first, 8 in the second, that gives us up to 10 altogether that we've drawn so far. It's got 17, so you're drawing the final shell 7. Second thing I asked you to do was tell me how many electrons in the outer shell. So this one, or how many they need, to have a full outer shell. This one needs 1 more. And this one also needs 1. I've drawn that as E minus, that is basic, that is just electron. In case we're wondering what E minus is, that's just a shorthand way of saying electron. So this one needs 1 electron, that one needs 1 electron. I've added the rest of the answers to the board now. So this one, oxygen's got 2 and then 6, because it's got 8 altogether, and it needs 2 more electrons to get that full outer shell of 8. Same for this oxygen here, also needs 2 electrons. And down here we got similar, 2, 8 and then 6, so that one also needs 2 electrons, and here 2, 8, 6, so it also needs 2 electrons. So we now know what they all need, And now we can move on to drawing the actual covalent bonds, because at the minute we've just drawn the atoms out. We've decided what they need to be able to have a full outer shell. We now need to know how to draw this, how we can actually have this happen. Okay, so now that we've worked out what each of them want in or what each of them need to have a full outer shell, we can draw the covalent bond. So the covalent bond is the solution for both of these to have a full outer shell, and it's all to do with the electrons being shared. So covalent bonds are always bonds where they are sharing electrons, and the way we draw these is just drawing the outer shells. We show an overlap where these electrons they both want an extra one, so they're both going to share one of them with each other. That'll make more sense once I've drawn it. So I draw just the outer shell. I draw them overlapping a bit like a Venn diagram. I draw it exactly as it was up here. So 2 there, 2 there, 2 there. This outer one works on its own. I just pop in the middle, that Venn diagram. Put my F in the middle, got my other F, and then same, dots, exactly how it was. Final dot I'll put there. And now you can say that that's a finished covalent bond, because when you count up, both of them have got 8 electrons in their outer shell. So 1, 2, 3, 4, 5, 6, 7, 8. And this fluorine one, 1, 2, 3, 4, 5, 6, 7, 8. That's how you can test that you've drawn the covalent bond out right, because they've now both got in their outer shell the right amount of electrons. What I'd like you to do now is, in a moment, pause the video, and I'd like you to have a go at drawing the covalent bonds out for Cl2, O2 and S2. I've just simply drawn out the outer shell just to make some space for me to write the answers, and also just to make it really clear what they need. So use your information from earlier, your answers from earlier on how many electrons each of these need. Try and draw a covalent bond where they're sharing electrons. Okay, so if we're going to go through Cl2 first together, they both need 1 electron, so they're going to share one. So we draw that outer electron with a shared part of it, so they're overlapping, and then you simply draw it how it was earlier, the outer electrons in the outer shell, dot. And then you can just check you got it right by counting 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And they're sharing electrons, which makes a covalent bond. So I've just added the answers for the following two. As you can see, I've just moved it slightly round, but what you have here is, because they both needed 2 electrons, they've shared 2 each, so there's 4 in the middle here. And the reason we can, or the way we can check that this is correct, even though there's so much in the middle, they're sharing so much, is counting. So we've got 2, 4, 6, 8 in that shell, and same here, 2, 4, 6, 8. So there can be more than just one thing in that sharing part of the diagram. And in this case, there's 2 from each atom, so there's 4 altogether shared. Same here, we've got 2, 4, 6, 8, so we've got the right number, and on this side 2, 4, 6, 8, we've got the right on that number, and they're sharing more than 1 each because they needed more than 1 each. So the number that they need is the number that they're going to have to share to be able to get off the other person. Generally. We're going to move on to some more difficult ones now, where there's multiple things going on. So we're going to try and draw the covalent bond H2O. It's a little bit more complicated because we've got 3 atoms. We've got 2 hydrogen atoms and 1 oxygen atom, and they covalently bond so that they've all got full outer shells. Hydrogen then, so we draw the first the whole atom for hydrogen. First shell's got 1 electron, hydrogen's only got 1. Second atom of hydrogen, because there's 2 atoms of hydrogen there, just 1 electron. Oxygen, 2 in the first shell, it's got 8 altogether, so it's going to have 6 in that outer shell. I'm going to draw it like this, just to make it really clear. Doesn't matter where you draw the electrons, but I know from practice where to draw them to make it a clear diagram in a minute, so you can see exactly what the electrons are doing. So this one needs 1 electron, So I'll just put needs 1 electron. Also needs 1 electron because, and if you're thinking, well, no, it needs 7 electrons. It doesn't need 7 electrons because it's the first shell. You can only put 2 in the first shell. So it just needs 1 electron. In this shell, we've got 6 at the minute. It's got a maximum of 8 in the second, so it needs 2 electrons. Okay, so we've done the first 2 steps, or the first step, and now we need to draw it as a covalent bond. It's not just going to be 2 circles overlapping, because we've got 3 drawn here. We are just going to draw the outer shell, so I'm going to start with oxygen in the middle, so I'm going to draw 2 there, 1 on either side, and then the 2 at the bottom. These ones are going to have to overlap somewhere to gain 1 electron and also to share 1 electron with oxygen. So I'm going to draw 1 here, and I'm going to draw the sharing electron there in the middle, the electron that's come from hydrogen, which is a cross, and the other hydrogen with a cross. And that is it drawn. Now we can check it's right because this hydrogen only wanted 2 electrons because it's its first shell, so it's got 2. This hydrogen only wanted 2 electrons because it's its first shell. It's got 2. Check oxygen, 2, 4, 6, 8. Now this, I've drawn this many times, which is why it's drawn so neatly, and I've known already where to draw the electrons. I knew to split these up so that these hydrogens could nicely fit on. It does not matter how it's drawn. So it doesn't matter how it's drawn, as long as you've got the right number of electrons in the right shells. It doesn't matter how it's drawn, as long as, like I say, there's sharing electrons happening and there's the right number of electrons in the right shells. You should now have had a bit of time to be able to draw out the atoms for carbon and hydrogen, and then work out how to draw the covalent bond. It is a little bit trickier, so don't get upset if you weren't able to do it the first time. It does take you a few times sometimes. But if you follow my step-by-steps that we went through a minute ago, you should be able to do it. So first things, draw out the carbon atom. Carbon has 6 electrons, so you draw 2 in the first shell. Maximum is 2, and then you draw the final 4 in that shell. Hydrogen, you're going to draw with dots just to show the difference. Only 1 in the outer shell because it's only got 1 electron altogether, so I'm just going to draw 1 for each of the 4 hydrogens because there's 4 hydrogen atoms. That's what that 4 stands for, so I've drawn 4 hydrogen atoms. You then need to work out what each of them need. I'm not going to write this out, I'm just going to verbally say it. So this one would need 4 to get up to 8. This one would need 1. This one would need 1. And if you're wondering why I'm not saying 7 here, because it needs to get up to 8, it's its first shell. Hydrogen's only got 1 electron, so that's its first shell. And in your first shell, you can only get a maximum of 2. So it only needs 1. Only needs 1, and only needs 1. So you now need to work out a way of sharing these electrons based on how many electrons they need. So my first thought is that this one needs 4 electrons, and there's 4 of these needing 1. So you could share 1 from each of them to get up to the 8. I'll show you what I mean. So draw out your carbon with just the outer electrons. So we're drawing a covalent bond, we don't draw the inner electrons. And then I'm going to draw 4 overlapping shapes for the 4 hydrogens with a dot in each of them, sharing bits. So now we've got 2, 4, 6, 8 in that carbon's outer shell based on the 4 that it's gained from 4 sharing hydrogens. And each of the hydrogens has got 2, 2, 2 and 2. So they're all happy, they've all got that full outer shell just based on sharing.